So on page 256, let's say problem
3-2. I mean 4-2.
4.1.
What's the title of 4.1?
Yes, it's 4.1. I would like to look at problem 40 on page 256.
Is this going to get in the test?
Absolutely. 4x minus y equals 7, and 2x minus 3y equals negative 9. We're asked to graph and solve the system. Remember, graphing, it's not something that I disregard. It is a legitimate method. However, requires time. A lot of time. Yes?
When we actually have action tests, is there going to be graph driven?
Yes. Yes. However, we are going to solve it algebraically to make our life much easier when we graph it. So we're asked to solve the system by graphing. What did we do last time? What did we do for a long time in this class when we had two equations to find the solution for? Correct. So obviously from which equation?
The top.
Correct. So then from here, if you want to move 4x to the other side, you will have negative y equals negative 4x plus 7. And then finally, you will say that y is
4x plus 7.
careful. If you multiply, you have to multiply everything both sides.
Oh.
Minus 7. This times negative 1, this times negative 1, this times negative 1. What do I do with this now? Very good. So this will get actually 4x minus 7. Agreed? Good. So then I have, can anyone dictate the second equation? The second equation starts with 2x, right?
So 2x
Yes.
minus
Yes.
7
There is a 3 here.
minus 3
Yes. Parentheses. 4x minus 7 equals. Please solve this equation 1 minute. And please give me x. How much is x?
3.
Do you all agree with 3?
I don't know, because I guess. Yeah, I got it.
Did everyone get 3?
Yeah.
Wonderful. So let me show you what I did. I copied 2x, I distributed negative 3, and I got negative 12x. Negative 3 times negative 7 is positive 21, and negative 9 on the other side. Yes, please.
Okay, question.
Please.
How do we know we're supposed to be combining these problems?
You're saying, how do I know that I have to solve the first equation for y and plug it in the second equation? Very good question. I have no other way. I cannot solve an equation with 2 variables in it.
Okay.
So when I have a system which consists of 2 equations in 2 variables, I immediately think, how can I solve the first equation for 1 variable and plug it in the second one to make 1 equation with 1 variable? Because that's all I know how to solve. So once I solve the first equation for y, and I replace in the second equation, now I have an equation that I can solve because it has only one variable in it.
Okay.
Here, two variables. I don't know.
Yeah, I see.
Here, two variables. I don't know. But once I solve this equation for, it's an excellent question. When you ask questions, you're helping me become a better teacher if you want, but better at explaining this.
Okay, well, so you say how that equation basically like y equals mx plus b. What about
Right.
the other one? Why would you solve that one for y equals mx plus b?
Excellent. Because I'm not looking for the slope. Very good question.
Yeah.
It's a very good question. I'm not looking to determine the slope and the y-intercept. Although you can say, but you're asked to graph. Why don't you just use that to graph? True. But I want to find first the solution, so I don't have to try to figure out the solution from a graph. It may take me 10 minutes. But this should take me 3 minutes to get the solution and then graph. So this is basically done on the side because I'm asked to solve the system using the method by graphing the equations. But when I graph them and I see this, I may not be able to, my graph is not going to be perfect. And it may take me a while to figure out and, just guess that solution. Instead, I already did my algebraic proof. I have the solution. It's not going to take me more than a second to read the solution from the graph. It's only because graphing is more complicated because I don't have graph paper. The x and y-intercepts may not be integers. So for example, if the x-intercept is the y-intercept is 0, 2/3, that would be difficult to plot 2/3 on the graph. And then I have to go back and use the slope and find points, and it may be more difficult. So I recommend do the algebraic part first and then graph. It will take you a blink to graph.
Why isn't it not -2? You did 2 minus 4.
I don't see the 2 minus 4. Where do you see it?
2x minus 4x.
Here?
2x minus 3 in parentheses 4x minus 7.
Right. So 2x is copied. -3 times 4x is -12x. -3 times
okay,
-1 is 21, and I copied
I
-9.
just forgot that you was here. I just forgot something.
So 2x minus 12x is -10x. Then I move 21 to the other side. I get -30. Divide both sides by
I get
negative.
it. I just missed one step.
That's okay.
I did,
So
I
now-
forgot to
That's
do it.
okay.
Once
So
you
now I
do
go
that,
back.
You need to plug it back into the
Exactly.
original equation.
Exactly. In this one. In this one.
Yeah.
So 4 times 3 is 12, and 12 minus 7 is 5. So then I know that y is 5. I already did my work algebraically. I know the solution. What is the solution?
Is 3 times 5.
Good. I will check the solution just to make sure. Okay? So let's go back to the original problem. I replace x by 3 and y by 5. Let's check, please. 4 times 3 is 12. 12 minus 5 is 7. Check. 2 times 3 is 6. -3 times 5 is -15. Is 6 minus 15 -9?
Yeah.
Yes. Otherwise, this will not be the solution. It has to check both equations. How come? Look at this. This is a point on both equations. That's why it has to check both of them. Otherwise, it's not the point of intersection. Correct? Good. Now I'm ready to graph. I know the solution. I know everything now, and I'm ready to graph. So I have 4x minus y equals 7. When x is 0, how much is y? Careful. Very good. So I have 0, -7. When y is 0, x is?
I thought y was
7 over 4. Have to divide both sides by 4 to determine x. So 7 over 4. Yes, go ahead.
I thought y was 5.
Yeah.
You just plugging it in to make sure.
So one more time.
Oh, y was
This is the solution, final solution.
So what you doing?
So why are we graphing that point?
Because I'm asked to graph the lines.
Um,
So I have to graph those lines, and they will meet where?
at that point.
Exactly.
Okay.
I will use the point in a minute, because I don't have to spend 5 minutes or 10 minutes to try to guess it, right?
Yeah.
Because I already have it, but I have to graph the line using the X and Y, the lines using the X and Y intercepts, and this point will be, for sure, because I checked, will be the point of intersection.
So how do we know when to graph and not to graph? Because this doesn't say nothing about graphing.
Okay, where I'm asked to graph it. But if I graph it without solving it algebraically first, it will take me a long time to guess the solution. And I don't want to spend the time on guessing the solution from the graph. You can disregard this part if you want to and just graph both of them. And if you are able to read from your graph, I'm not able to read from it.
So the solution is the graph.
We didn't get to that. We're trying to graph each line right now.
That's why I'm saying it says determine whether each ordered pair is a solution.
I picked problem 40. I picked problem 40, which is solve each system of linear equations by graphing.
Oh, I'm at the top. Okay. Stop.
So now I have 2 points. So your question, coming back to me. So when x is 0, I'm finding the x and y intercepts. I'm given this equation, I'm asked to graph it. This is what we studied in chapter 3, right? When x is 0, y is -7. Do we understand this point? When y is 0, do we understand x is 7/4?
It's the same one, right?
Yes. I'm trying to graph those 2 lines to show that the solution will be 3/5. Okay. Just making sure. So is the other ordered pair 7/4, 0? Is this correct?
Yeah.
Okay. So then I'm going to plot these 2 points. And I find -7, 0. I'm sorry, 0, -7. 1, 2, 3, 4, 5, 6, 7. And 7/4 is a little bit less than 2 right here. So this is the first line. I need to write somewhere the name of this line. This is the name of the line. 4x minus y equals 7. Now the second line is 2x minus 3y equals -9. I need 2 ordered pairs. When x is 0, how much is y?
3.
So this is 0, 3. When y is 0, how much is x?
-9/2.
Do you all agree with x is -9/2? This is what we did in this chapter. So we need now, at this point in time, we need to know how to graph lines, finding the x and y intercepts. I have to rely on that. As I do rely on you to review how to add fractions.
Can you slide it down some? It's just too cold. Gosh.
We are graphing lines that we've been doing all this.
I mean, by the time you, because I get confused. I do one, and then when I get to the other one, I'm like, okay. Because when I think I'm finished, obviously I'm not.
So which part was confusing here?
Everything. She said.
So then 0, 3 is this. And -9/2, which is -4/5. -4.5, I meant to say.
You didn't graph 7/4.
Yes, I did. It's a little bit less than 2. 8/4 will be 2. 8/4 will be 2, so I graphed it a little bit before 2. I plot the point before 2.
Oh, okay. I see what you're saying. I'm like, how did you get to the...
8/4. 8/4 is 2. 7/4 must be a little bit less than 2. Okay. So now I graph the second line, which is 2x minus 3y equals negative 9.
And real quick, you just put that exclamation. I just want to be sure I got the. Okay.
And now from this graph, I'm going to ask you to forget anything we did before graphing and give me the solution. So obviously they meet in one point. So this is the solution. Forget about everything else we did before.
3, 5. 3, 5.
Because you knew what we did before. But can you really read 3, 5 from my graph? Really?
No.
No. So that's what I want to avoid. Look what I have here. So this is my 3. This cannot be my 5. So this is my 2. This cannot be my 3. 3 should be here. Because my graph cannot be perfect. So that's why, and it would have taken me like forever in this case to figure out what that point is. But since I did all my work algebraically, which I know how to do, right? I already have the solution. Now I'm not going to spend 5 hours on this. And I just put it.
Do those steps to learn to vote.
You mean graphing?
But you already have.
But the question is asking us to graph.
So if I go get graphic paper, this would be more accurate.
It will be still difficult. Let me explain why. Let me explain why. Because, for example, this point is 740. That will be very difficult to plot, even with graphing paper. Because you will have to divide the unit in exactly 4 of 1/4, 1/4, 1/4, 1/4, 1/4, and then put the point there.
Okay.
It will still be difficult.
Yeah.
And you can ask, why do we even study graphing, solving systems by graphing? It's a legitimate method. It can be done with the calculator. That it can be done. And the answer will be exact. Okay, so I can show you how to graph these two with the graphing calculator. And how to read.
Can I see that?
Which one?
The paper was
Which one?
the paper was up there.
So let's take a look. So now with the graphing calculator, you can, in y equals, you have to delete everything else or clear everything else you have. And I will put the first function, which is 4x minus 7. And the second function has to be solved for y, because the calculator won't allow me to put it in. So I have negative 2x. Can I get a blank sheet of paper? Not that one, the next one. So I have 2x minus 3y equals negative 9. Negative 3y equals negative 2x minus 9. So y will be 2/3 x plus 3. So I solve the second equation. In parentheses, I have 2 divided by 3, multiplied by x, and plus 3. So once I put these two equations in, and I go to Zoom and I choose 6, you will see what happens. This is the first line. This is the second line. And guess where will they meet? Comma. Right. So I can even find that with second and calc. And I'm asked to find the intersection. So I'm using 5. So it says, is this the first curve? Yes, it is. Is this the second curve? Yes, it is. And now I don't want to guess, although I know the number. X will be 3 and Y will be 5. I press enter, and it will give me that answer. So this is This is a useful method, knowing that we can solve systems by graphing. But on paper, for us, by hand, is very difficult to find that solution. And here is my example. Can I get that for a second? So as you see, in my situation, I had no way of coming even close on the graph with 3, 5. I would have probably needed I don't know, half an hour to get that far. Yes, Tim?
Is there any particular reason why we don't use 3, 5 as one of the points for each lines?
How will you determine it?
No, I mean, since we've algebraically determined.
Oh,
those
yeah,
as
you are
both
saying
those lines, why do we
determine
have
just
to
one of the
do
two.
additional points
That's fine, you can,
on
but
top of the
you
2?
can, but when we graph without knowing the solution, we have to graph using the x and y intercepts. So we will not know that that's 3, 5. But yes, when you finally graph it, you can use that as one of the 2 points instead of finding the other. However, I would like you to get used to always finding the x and y intercepts for a function, especially if they exist. These are the most important points. Yes, please.
And whenever we're doing that, we always take like, if it's y, we have to make it equal to 0 to solve for x.
These are the x and y intercepts.
Yeah.
Yes. So when I determine the x-intercept, I have to make y equal 0. When I find the y-intercept, I have to make x equal 0. Okay, now you can have it back if you need it. Any questions? Okay, so let's go back to let's look at another one. I'm not sure we did 30. Did we do 30? Maybe we did. I think we did. Did we do 30? Okay, very good. Let's say we didn't. We're asked to solve by graphing. You can say, I don't want to do the algebraic proof. I'm going to go directly to graphing, and that's fine by me. I would personally never do that. I will solve the system algebraically. I will check the solution I get, and then it will take me another 3 minutes to graph and forget about it and move on. So which would you prefer to do? Yes?
The first problem would be, we would make it x equals negative 3y plus 7.
Next step.
Plug it into the method.
Can anyone dictate the second equation in which we need to plug in? Because we want to find the solution algebraically. It doesn't matter. I'm not going to solve for y because I have to divide by 3. I will always solve for the term or the x or y that has 1 in front or negative 1. Because if I solve for y, then I'll have to put a fraction in here, and I don't want to do that. 2 parentheses. Perfect. Let's solve this equation for what? Of course. Very good. Now, one more time just to make sure. Do we understand why we're doing this algebraically first? Is everyone in the clear with that? Yes, because it's hard to read from the graph. But you can say, and I'm fine. You can say, no, I want to graph. I will graph very accurately, and I don't need to solve this first. And I will be okay with that. So how much is y? So you got negative 6y plus 14 minus 3y equals negative 4. So negative 9y equals negative 18. So y equals 2. Do you all agree with y equals 2? But then can you give me x? One indeed. So what do you expect the ordered pair, the solution of the system, to be? Right. Don't trust it though. Let's go back. Let's go back to the system. 1 and 2, 1 and 2. 1 plus 6 is 7. 1 plus 6, is that 7? Good. 2 minus 6, is that negative 4? 2 minus 6, is that negative 4? Yes. So now no one can find another point. This is it, for sure. Now forget about this, and let's start graphing it. Any questions for me? I'm sorry? I made the mistake of not numbering them. Okay. Are we okay with this? Perfect. So now I have x plus 3. So the system is x plus 3y equals 7 and 2x minus 3y equals negative 4. So for x plus 3y equals 7, when x is 0, how much is y? 7 over 3. So then 0, 7/3. Any questions? So finally, when y is 0, x is 7. So 7 comma 0. Ready to graph the first line? So 7 comma 0, 1, 2, 3, 4, 5, 6, 7. And what is 7/3? A little bit more than 2. So here it is. Don't forget to write the name of this line. And that is the equation x plus 3y equals 7. We will repeat with 2x minus 3y equals negative 4. When x is 0, how much is y? 4 over 3. So 0, 4/3. And when y is 0, how much is x? Negative 2. So negative 2, 0. Very good.
What do you say?
Here. Here.
Okay.
So negative 2, 0. And 4/3 is a little bit more than 4/3, a little bit more than 1. Very hard for me to graph something like this with a marker and show you and so on and so forth. So this is 2x minus 3y equals negative 4. Now can anyone read the solution? Guess the solution. Can you guess the solution? Say it again.
I mean, it's 1 and 2.
Of course. I'm just making a point. It's hard for me to read, right? Maybe this for this particular problem is a little bit easier than the previous one. But yes, of course, the solution is 1 comma 2. Any questions? Okay, I think we should go back. Have we had enough of this? Is this okay?
Maybe just 1.
Okay. Okay, very good. So let's look at, let's say, 23. However, remember, we did a couple of in class. If you don't do another 20 at home, you will have difficulties, or it will take you long time. So you have to practice this. Very good. 23. Y equals negative x minus 1, and y equals 2x plus 5. We're asked to solve by graphing. However, if you want to go ahead and graph, go ahead and graph. I prefer doing the algebraic part first to make sure that I don't spend time on guessing. Can anyone give us the first step? Please.
Set negative x minus 1 equal to 2x plus 5.
Absolutely. By simply looking at it, you saw that both of them are solved for y, and they have to be the same thing. Any questions? Any questions? So y equals negative x minus 1, but it's this y. So this has to replace y. That's how we get negative x minus 1 equals 2x plus 5. I can combine because I have to move terms around first, right? There is nothing I can simplify. So this has to go here and this has to go here. So negative 3x equals 6. I subtract 2x from both sides. I get negative 3x. I add 1 to both sides and I get 6. So then x equals, careful, negative 2. Now let's go back and replace it here. Or here, it doesn't matter. Go anywhere you want and just give me y. And then we'll check. Say it again. So when I plug in negative 2 with minus in front, it'll become 2, and 2 minus 1 is 1. There is a negative in front, and this is a negative number. So the ordered pair appears to be, careful,
Negative 2 comma 1.
perfect. Okay, so then I go back and check. I must check. So 1, negative 2, 1, negative 2. Let's check. Negative 2 with minus in front is 2, minus 1 is 1. Check. 2 times negative 2 is negative 4, plus 5 is 1. Check. No one can find another solution. This is it. Yes, questions?
No, sure.
Okay, I'm sorry? Now I graph because I already know the solution. So I will be graphing the first line, which is y equals negative x minus 1. When x is 0, how much is y? So 0, negative 1. When y is 0, you have to move negative x to the other side. How much is x? Move negative x to the other side. How much? Move negative x to the other side, it becomes positive x. Positive x equals negative 1. So negative 1 comma 0. Now we can graph. The first line has negative 1, 0, 0, negative 1. So I graph the line. So this is y equals negative x minus 1. The second line now, y equals 2x plus 5. When x is 0, y is? Good. So 0, 5. When y is 0, this is a little bit more complicated because I have to move 5. So when y is 0, I get 2x equals negative 5, or x equals negative 5 halves, or negative 2.5. So negative 5 halves comma 0. So negative 2, this was negative 1. So negative 2.5 and 0 comma 5. This is the equation y equals 2x plus 5. And now let's read the solution. Not from my graph, actually. Look at where my y is. Not at 1, for sure. My units are not perfect, and so on and so forth. So what is the solution? Because we already know it and we checked it. What is it? A negative 2 comma 1. Could you have read maybe from your paper? Maybe you could have, but I could have not.
So this is just, we don't necessarily have to do the extra step. This is just checking.
This is what you have to do. But if you do this like I did it here, I would have never come up with a solution. It would have taken me a lot of check and trial and error, which I want to avoid. So I did everything algebraically. I solved it algebraically. I had the solution, and then I graphed and I said this is negative 2, 1. Because I can't be super accurate on paper, especially when I have markers that I write with. This is what you're supposed to do. This is the extra that gives me confidence and in finding the solution and not having to do trial and error for a few minutes.
What page is this?
You mean the problem? It's in 4.1 on page 256. Okay, can we go back now to 3.6? Any other questions on this problem or the others that we looked at? Is it clear what we're trying to do? Yes? Okay, so let's go back to 3.6. I'd like to practice a little bit more in 3.6. From the test, chapter test review on page 244, I would like to look at problems 101 through 104. So 101 through 104 on page 244. So let's start with 101, and here's the graph. Negative 3, 2, and 5, negative 4. This is the graph, and we are given this point, negative 3 comma 2, and we are given this point, 5 comma negative 4. We're asked a lot of things here, and I'm going to add a few questions, like we had on this quiz today. So first of all, we're asked to find the domain and range. Can anyone give us a domain of this function?
Bracket negative 3 times 5.
So remember, we read the domain of a function on the x-axis from the leftmost point till the rightmost point. Leftmost point has x negative 3, rightmost point has x4, x5.
And because,
Exactly.
yeah, I think that's exactly what I was asking.
Yes.
Because because that dot's closed, that's
Cor-
why bracket.
Correct. What about the range? I have to start from below to above. On the x-axis, I start from left to right, but for the range, I start from the lowest to the highest. So the range is negative 4 comma 2 indeed. I'm going to ask a few questions in addition to what they asked us here. They are asking only domain and range. So here's what I want to add to this. Find f of 1. How do I find f of 1? Yes. How do I graph the line x equals 1? Very good. Very good. So this is y x equals 1. Does it cross the function? Oh, I forgot to ask you. Is this a function, by the way? By the... Good. So then I see it crosses the graph in 1 point. Can anyone read the y value for us? Negative 1. Can anyone give us the point that you read from? 1 comma negative 1.
So we back up just for 1 second. So it was originally find a function of 1. So that's kind of like where we drew like a imaginary line where x equals 1. And then from that we look at where the 1 would cross the line that we have.
The function. It may be a line or not. So where it crosses the function.
Where that 1 crosses the function, and that's negative 1. And that's where we get
That's the y value
that's
that
the
we
y
read.
value. So that's where we get that where from.
Yes.
And negative 1.
Yes. X-intercepts, if they exist. Does this function cross the x-axis? Approximate? No, the x-intercept cannot have x0. So the x-intercept is right here when x is and y is. It's a negative side, so it cannot be. So, oh, y is 0. Yes, I thought you were talking about x. I'm sorry. Yes. And x is? Very good. So then the ordered pair is? What about the y-intercept? Does this function cross the y-axis? Good. Can anyone give us the x and the y? Very good. Of course, it's on the y-axis. And the y? Good. Negative 0.5. So 0 comma negative 0.5. Next question. Find x such that f of x is negative 3. What is given now? So y is? What type of line is y equals negative 3? Good. Does the graph cross? Does the line cross? The horizontal line cross the graph?
Yeah.
Good. So please read the x value for me.
X equals 3.
I'll say 3.8 from my graph. I accept both. So then 3.8 comma negative 3. Very good. Okay, problem 100.
So wait, so I understand these quadrants. 1 and 4 are x-axis, and I guess 2 and 3 are the y.
I'm not sure where are you looking for. Can you repeat?
I'm just looking at the graph, the quadrants. I'm talking about the quadrants.
Yes.
The right side, the x-axis, and the left side,
So you want me to talk about the quadrants?
Yeah.
Okay, so in a Cartesian system or coordinate system, this is the first, this is the second, this is the third, and this is the fourth.
Okay.
Can I see the sheet for that? I can make
But there's an x and y in each quadrant, right?
Yes.
Okay.
Yes. If you want to plot, say it again.
I just want to see the problem.
You mean the graph?
Yeah. I mean,
Are we gonna have to do our own graphs?
is this the whole problem right here?
And all of this
Which problem are we talking about? I'm not sure. Oh, the graph that we copied.
Yeah.
Yes, these are the questions referring to the graph. Now I was going to start problem 100.
Wait, and all like these kind of like problems are gonna be on the test.
Yes.
On today's test.
Yes.
It's on Tuesday?
Yes.
I feel like we ain't get real far today.
I'm sorry?
We spent a lot of time on homework. You can't push it back to Thursday?
You want to move the test to Thursday?
Yeah, I feel like we didn't get a lot of practice on it.
You feel that we didn't have enough practice on this?
Yeah,
I'm fine to answer. I don't have a problem moving the test to Thursday, but I have to start chapter 5. I can't. I need a month and a half on 5 and 6.
I was
Your
just saying because
our
we spent a
head-
lot of time on
our
it.
head will explode in chapter 5 and 6. I need a lot of time.
Are those the last 2 chapters?
The last 2 chapters are 5 and 6. Yes.
So wait, if our head's exploding now,
Say it again.
it's.
I couldn't hear you, Derek. I couldn't hear you. If you'd like to repeat.
Never mind.
You see the certain X-ray in the whole room?
So I don't have a problem if you'd like to move the test to Thursday. I'm fine, but I will answer all your questions. I can use another class to review from scratch. I don't have a problem with that.
Can you go up a little bit? Let's do that. Thank you.
I don't have a problem with that, but I have to start chapter 5 because chapter 6 will take a long time. Factoring.
Cut our time for the test in half to be able to start chapter 5 and 6 or something.
What?
Well, you mean for Thursday?
Well, you said we gotta start like next Tuesday. I guess now the test would be next Thursday.
I don't recommend postponing